Okay, looking at this problem number 80, it's an application problem, and here they say find the change in cost C, okay, which is what we have here. So find the change in cost C, okay, for the given marginal. And they say in each case assume that the number of units X increases by 3 from the specified value of X. Okay, kind of a complicated problem, I suppose, in the directions, but after you see one you'll kind of get the habit. They're basically asking us to compute a definite integral, and we'll kind of talk about what it means. So what we have here is the derivative of the cost function. Okay, so that's important here. This is what they call marginal cost. Okay. Okay, and again, what does marginal cost tell you? What does this formula tell you? Well, marginal cost is the derivative of the total cost function. Okay, so it tells me the rate at which cost is accumulating. Okay, so for instance, by the way, I might call this function, instead of dc over dx, I could call it c prime of x. Okay, well, if we put a number into this function, it tells me the additional cost per additional unit when we produce that number of units. So for instance, if you put, let's just say c prime of 100, you know, what does that mean? Well, what is this going to be? It's going to be 20,000 over 100 squared. 100 squared is 10,000, so that's going to be 2. Okay, 2 what? Well, $2 per additional unit produced. Okay, what that means is that when this company is making 100 units, the cost is increasing at a rate of $2 per additional unit. Okay, so roughly, you know, we're going to spend $2 to make that next unit, the 101st unit, when we are already producing 100. Okay, now if we're producing 1,000,000 units, probably the additional cost for making the next unit is much smaller than this. That's the way businesses tend to work and tend to operate. Okay, but the question they give is this. They say find the change in cost, okay, for us, since this is a marginal cost. So we're going to find the change in cost when we increase the number x from the specified value by 3. Okay, so find the total change in cost. Okay, again, the wording's maybe not the best, but well, we have here a function that represents the rate at which cost is increasing. And if you want to total up a rate of accumulation, right, that's the rate at which cost is accumulating, we integrate the marginal cost function. Okay, so what they're asking us to do, I think they could say a little bit clearer, but they want us to find the cost of producing units 10 through 13. Okay, the units maybe between 10 and 13 would be better. So kind of imagine the problem here. Let's suppose you want to increase your production from 10 units to 13 units. How much are you going to spend to make those couple of units? Okay, well, to do that, to answer that question, we need to add up the cost, the marginal cost, from 10 to 13. Okay, so when you total up the accumulation over some interval, that's a definite integral. So we need to integrate this marginal cost, okay, with respect to x, from 10 to 13. So we're going to integrate from 10 to 13, okay, the function 20,000 over x squared. Okay, because that's the rate we want to accumulate over this interval of units. Okay, so I mean, I think once you kind of break it down to that sort of problem, there's really nothing new here. I mean, it's just a definite integral. There's some bigger numbers involved, but nothing too tricky here. Okay, well, to do this definite integral, I might use that constant multiple rule just to get the 20,000 out of the picture. Right, I can factor a constant outside of a definite integral, just like an indefinite integral. Well, that's going to leave me 1 over x squared, okay, which I'm going to write as x to the power negative 2. Okay, just do that here so I don't have to do it in the next step. And that'll give me 20,000 times, okay, and here's where I want to use calculus. I want to go ahead and find an antiderivative of x to the power negative 2. Okay, well, I can use the power rule here. It's x to a power. Okay, so I get 1 over the old power plus 1 times x to the old power plus 1. Okay, that's my antiderivative. Remember, I don't need a plus c since this is a definite integral. And once I simplify that, I want to substitute the limits in. So I always write this bar here. The book sometimes uses a little square bracket, and there's no big difference there. But I have to do that yet as well. Okay, so mostly just algebra from here on out. Okay, this is, actually we did this one in an earlier example. This is going to be 1 over negative 1, so negative x to the power negative 1, which is just negative 1 over x. Okay, so I've got just to put those numbers in, and let's see what we get. So we're going to get 20,000 times, and then just substitute the limits in. I have to put 13 into this antiderivative, so that's negative 1 over 13. Okay, minus, and here I have to put 10 into the antiderivative, so that'll be negative 1/10. Okay, and you have to be careful, with the minus signs, because here we're subtracting a negative. But this is just 20,000 times negative 1/13 plus 1/10. And again, instead of doing all this nasty work with fractions, you can use the fact that it's a word problem, so we don't need to to use all the fraction stuff. We can just go to the calculator and get a decimal answer. Decimal answers are always okay in a word problem. So let's see here what we get. Okay, use my little computer calculator here. 20,000 times, okay, the quantity negative 1/13 plus 1/10. Okay, so here's what I get. I get about $461.54. Okay, so again, what does that mean exactly? Well, it means that to move our production from 10 units to 13 units, we're going to incur an additional cost of about $400. Okay, and that's pretty reasonable, I suppose, if you look at the marginal cost at 10. So if you put 10, whoops, I'm back up here, into this function, the marginal cost is actually, I think, about $200. So to go from the 10th to 11th unit, cost is going to be increasing about $200. So what we've done here, though, is we've actually just kind of added up that rate of accumulation exactly using calculus. So integrating the function from 10 to 13 is kind of the quick way to total up all of that additional cost. And here's what we get, about $461 to move our production from 10 units to 13 units. Okay.